Thank you. Thank you. Can you hear me? Okay, so was done not completing the project is completing it and finding out that it is unusable. And this is a situation we found ourselves in at the beginning of this year. So today I'm going to be talking about lessons we learned from this incident. First, introduction. I am Chinenye Onuegbe, and I work for Yilu. Yilu is a travel-focused company in Berlin. And before Yilu, I used to work for Zalando, which is actually where this happened. And so, the situation, what happened? We were two very experienced JavaScript developers, but we were new to React. This was actually our first React project. And we learned the hard way that a good JavaScript engineer is not a good React engineer. And we were working on a back office application. I mean, when you're working on an application that only the internal staff uses, you usually don't think of performance as the first thing. The first thing you usually think of is, you don't even think about how it looks. You just care that it's functional. So, sorry I cannot present the actual screenshot because I no longer work at Zalando, and I do not have the permission to do that. But this is what it basically looks like. So, as you can see here, this is what we call campaigns. So every week we have campaigns, and in each week we have different campaigns. So this, as you see here, indicates the current week, and this indicates individual campaigns. So every campaign here belongs to this week. Every campaign here belongs to this week. And this indicates the active campaign. That is the campaign that is selected by the user. When the user selects the campaign, some options pop up like delete campaign, edit campaign, and so on. So the requirements for this app is that we show at least 26 weeks at a time, because we show it half yearly. We show the half-year campaign at a time. And it's up to 50 cards per week. So in a week, there could be up to 50 campaigns. And when you do the math, it's about 1,300 campaign maximum, at least, at a time. And it has infinite scrolling. So as you're scrolling, more campaigns are showing up. So if you scroll too far down, you're going to have maybe 10,000 campaigns showing on a screen. And we had a Redux store. Who here uses Redux? Yep. Some people think it's old-fashioned, but if you work in actual applications, if you're not designing libraries, you find out that Redux is still very, very important. And one requirement is that the state must be serializable, because this application automatically logs you out in 1 hour. And sometimes users are making changes and they want to save this change and they're logged out. You cannot tell them, oh, you are logged out, so you have to repeat all the changes. So we have to save the state, and when the user is done logging back in, we must resume from where the user stopped. So I have some code samples if you want to follow it. I'll be showing them here, but if you want to go at your own pace, it will be good to open it. It is actually pseudocode. It is not valid React. So don't be confused if you see some things that look as if they don't make sense, because actually they don't make sense. So the first lesson we learned is that wasted renders are really, really bad. And it's, can someone clap? I mean, it's not earth-shattering. It's one of the first things you learn when you learn React. But what we did not know is how difficult it is to actually detect wasted renders. And this was where our problems began. Knowing that you have to use pure components if your component doesn't change unless the prop changes. A lot of people know it, and we did know it, but beyond that, it really gets tricky detecting when you are going to have wasted renders. So every problem we had with this application had to do with wasted renders. And we didn't know how much wasted renders could really make your life miserable. So the second lesson we learned, which also has to do with wasted renders, is that data transforms are very problematic. If you are transforming your data remember that this application needs to be serializable, and we are storing some dates in this store. And between when we retrieve this data and when we use it, we have to somehow convert it back to JavaScript dates, for example. We have some custom data types but I want to use date as a well-known example. So how do you deal with this? I'm going to show some code samples. So here we have what we call calendar weeks. Remember our screenshots. In JavaScript, you only deal with dates. There is no way of dealing with calendar weeks in JavaScript. I mean, there is, but it's not really inbuilt in JavaScript. So if you, for example, want to add 1 week, or check if this week is before the other, or check if this week is in this quarter, or if it's in the next quarter, find the first week of the quarter, find the last week of the quarter, it's really complicated. So the calendar week, we had a class called calendar week, but we cannot store this class in the store because, again, the store needs to be serializable. So between when we need to use this class, between when we retrieve this class from the store and when we need to use it, we need to somehow transform it. And at first, what we did was something like this. Sorry if you do not understand TypeScript. This is written in TypeScript just to make it concise, because I don't want to go writing the whole stuff. So this is what our store looks like. The campaign contains a list of campaigns. And a campaign is serializable. The calendar week is actually stored as a string. It is stored as an ISO string in this format, 2019 week 01, for example. Can you see that? Oh, can you see my screen? Is it better? How do I enable Zen mode? Yep. So this is what a calendar week looks like in the store. But when to make it usable, we have to convert it to this class. So what we did initially was when we retrieve this item from the store in the get campaigns, this is a Redux selector. we convert this calendar week to calendar week. And I don't know if you already see a problem here, but if you don't see a problem here, I will tell you what the problem is. The problem is because of this transform, each time we call this stuff, it returns a brand new object. Even if everything in this campaign remained the same, it returns a brand new object. And because React decides to re-render a component if the props change, and React actually compares the props very shallowly. So if the object reference is different, it will force a render. So this caused us a lot of problems. It was difficult to track it down. And you can see, for example, here, how we use this. These campaigns are actually all the campaigns in the store. When something changes, we need to retrieve all the campaigns again. And because of this transform, all the campaigns were being retransformed. And this cost every single campaigns 1,300 campaigns at every time to render. So if a user clicks a button, 1,300 campaigns are rendering. If a user scrolls, 1,300 campaigns are rendering. I cannot begin to tell you how slow the application was. So how do we solve this? First of all, we First of all, we thought of two ways to solve it. The first way was to do the transform inside the component itself. So instead of doing a transform in the selector, we let the selector select exactly what was in the store and pass it to the component. The component will do the transform when it is needed. And in this way, we eliminated the having to recreate a new object every time. Then we also thought about reselect. How many of you have heard of reselect? So reselect is a library that allows you to basically do what we did before, but only generates a new object if the inputs change. So the second way we thought about doing it was getting rid of the transform completely, and getting rid of the calendar week class completely, and instead using functional approach. So a lot of the methods that we had in the calendar week, like is calendar week in this quarter, is this next quarter, could actually be done in a functional way. We could define a function that can compare to calendar weeks. We could define a function that will get a calendar week as a string and check if it belongs to this quarter. And this was the solution we ended up choosing. So what other lesson did we learn? So in case you don't know about reselect, you can check it out here. The second lesson, the third lesson we learned is that data structures are really important. So back to our screenshots. This is the active campaign, the currently active campaign. And how do we represent this in the store? Can anyone maybe give a pointer? We have a list of campaigns, and we want to indicate the currently active campaign. The obvious choice for us was sorry, wrong file. The obvious choice for us was something like this. So these are the list of campaigns. Campaign 1, campaign 2, campaign 3, campaign 4. And then we have a different key, campaign, which is the currently active campaign. And when there is no currently active campaign, this is null or undefined or whatever. This was the obvious choice, but it turned out to be very catastrophic. Why was it really bad? Why it was bad is because for you to highlight this campaign, you have to compare this campaign ID to the currently active campaign ID, which means you need to pass the currently active campaign ID to every single campaign card. Does it make sense? So we need to pass this campaign ID to every single item. And when the active campaign changes, what does it mean? We are going to render every single card. So every time someone opens a new campaign, it takes maybe 6 or 7 seconds for the whole UI to respond. And when someone deselects it, it takes another second for it to respond. It was difficult to actually track down because, of course, we were doing everything correct. We were doing everything right. And how did we solve this? By changing the data structure. So what we did is, instead of having an active campaign ID, we have an isActive property inside the campaign itself. So this way, if someone deselects a campaign, of course you know the campaign that was deselected, you know the campaign that was selected, and we find that campaign. This would mean that we have to iterate through the list of campaigns and find the campaign that has the selected ID and mark it as active, and check the list, find the one that was active before, and mark it as non-active. In JavaScript terms, this is not efficient because every time we have to iterate through the whole list in the worst-case scenario. But in React sense, this makes a lot of sense because iterating through a list of 1,300 campaigns in JavaScript turns out to be maybe 300 milliseconds, but re-rendering the whole campaigns does like 6 to 10 seconds. And I'm talking about when we have just one page. If the user has multiple pages of campaigns, this can be really problematic. So the lesson we learned is that the data structures that are good for general purpose JS may not be optimal for React. Sometimes in React, we've had the argument or the debate on how we want to represent data. Do we want to represent it as a map, for example, or as an array? I don't know how many of you has had to make that decision. For example, you need to be able to quickly find a campaign, for example, and do we represent it as a tree as a map with the campaign ID as the key and the campaign as the property? It will be very easy to find the campaign. Or do we represent it as a list, which means we are going to have to do array.find to find the campaign? In JavaScript speak, this is a very easy decision, but in React speak, it is not very straightforward because this can make or mar your application. The fourth lesson is that prop lifting itself is not bad, but it can compound an already existing issue. What is prop lifting? Prop lifting is when you pass the props. I'll show you in a code example. Here is a campaign card. I just want to define some terms. This is a campaign card, and this is a campaign row, and this whole list, this whole view is a campaign list. So it will help us in the next code that we're going to see. And think of when you're designing an API, and this is an endpoint to delete a user from your API. Would you rather go with this or with this? You'll probably go with the first one. But in React, users usually go with this. So I'm going to show you examples. Here, we are passing the campaign weeks. Campaign weeks is a map with the week as the key, and the list of campaigns that belong in that week as the property, as the value. So we pass this campaign weeks to this campaign list. Remember, campaign list is this whole stuff. And then this campaign list then renders the campaign row, the campaign rows, which is at least 26 at a time. And it passes the campaigns that belong in that week to that campaign row. And then the campaign row renders each campaign card, and then it passes the campaign that that card should render to each campaign card. So we are passing the props that campaign card needs. This campaign, for example, is needed by only campaign card, but we are passing that prop in campaign lists. So campaign list's job is only passing this prop down to campaign rows. It's not using this prop. And campaign rows is also not using this prop. So it's passing it down to campaign card. So what is the problem with this? We prefer to go with the approach that you only pass in what you cannot easily derive. For example, here, you only pass in the user ID. Why? Because you cannot derive the user ID directly. You need the user ID to delete the user. But passing the username, the email, and the user ID, just passing the whole user object, it doesn't make any sense. So what we do is, in campaign lists, instead of passing the whole campaigns, we get the weeks that should be displayed. So this is a list of strings, and we pass it to campaign rows. We do not pass the campaigns that belong to this week to campaign row. And the campaign row then gets the campaign IDs, not the campaigns. The campaign IDs that belong to this row, and then sends it to the campaign card. Now the campaign card gets this campaign by ID and then renders it. So campaign row does not pass campaign to campaign card, but it passes campaign ID. And how could this affect your performance? How it affects performance is that sometimes you need to write some custom update rules. If you use pure component, you know that pure component writes update rule for you. That's should component update. And if you use normal components, you have to write it by yourself. And when we started writing this by ourselves, we found out how difficult it is to compare two objects. It is not easy at all, especially if the object has nested objects. And of course, if you are dealing with serializable values, you are just dealing with strings, as we learned to do, it is not a big problem. But if you are dealing with complex data that has already been transformed, this can become problematic. Because we first tried solving this problem by writing should component update, but because of the way we were handling data here, it became really, really difficult. And another thing is that Here, each time we try to get the campaigns, because we have to adopt immutability, we have to regenerate the list of campaigns as a new array. So it may not be a big issue compared to the larger issue we had, but this costs every single row to render. The cards did not render, but each row rendered, and that's 26 unnecessary renders at least. So one other point that I did not put in this slide is, the lessons we learned is that we inject props close to where they are needed. Do not lift props. I mean, you can lift props if you want, if you know what you're doing, but lifting props can complicate issues. If you can generate the user object, for example, inside the component, if you can query the stuff from inside the component, you should better query the stuff from inside the component than trying to pass the user down. So if you use Redux, you probably adopt the concept of connected components. So we had the rule at the end of the day that each component should have a connected component. This makes it possible to be able to directly inject these props in this component. And second lesson learned here is that we only pass the props that can't be easily derived. For example, passing in the username and password and all this stuff that you can easily derive from the user ID is not optimal. OK, so micro-optimizations are not really important if you are dealing with React. Things like, should we define this function inside or outside so that we don't have to redefine it every time? I mean, it's nice to have arguments around those things, but we found out that these small, tiny optimizations, they don't even add up to 3 milliseconds of time. And sometimes it's not just, I mean, it's nice to have, but it's not worth worrying about, especially if you have bigger fish to fry. So that is it, and thank you for listening.